Hello all, welcome to AI Educator. In this video, let us learn how to build ANN functional model on Iris dataset. Functional model building is similar to sequential model building, with only change comes where building the model will perform all the tasks similar to the sequential model. First, we import libraries, then we load the data, then we split the data into X and Y, we encode the target data, and we split the data into training and testing parts. Now comes the model building. And here in model building, we build the functional API instead of sequential API like last time. First, we need to import few libraries to build the functional API model. They are from tensorflow.keras.models. We import model, and from tensorflow.keras.layers, we import input. Now let me run this cell. They got imported. Now let us create the model. First, we need to define a function to create the functional API. So I'm telling def ANN underscore model, and inside this, let us create the model layers. First, I'm telling the input as visible is equals to input of, inside this, I'm giving the shape. This will be the input shape. So inside the tuple, I'm giving 4. Since we have 4 columns, sepal length, sepal width, petal length, and petal width. And now let us create the first hidden layer. Let's call it hidden one, and which would be a dense layer. So hidden one is equals to dense of, here you need to specify the number of nodes. I'm taking 8. I'm giving activation function as relu, and this layer will be followed after the visible layer. This layer will come after the input layer. So we need to write visible like this. Now let us create the second hidden layer. Let us call it hidden 2 is equals to dense of 10 with 10 neurons, and activation is relu. The second hidden layer will come after hidden layer 1. So after this, I need to specify hidden 1 so that it is comes after hidden layer 1. Now let us create another hidden layer. Let's call it hidden 3, which is also a dense layer with 10 neurons, and activation as relu. Now this third hidden layer will come after second hidden layer. So hidden 2. Now let us create our output layer. Output is equals to, which is a dense layer again, dense of, here we'll take 3 nodes because we are doing 3 classifications: iris setosa, iris versicolor, and iris virginica. And the activation function as softmax because it's a multi-class classification. Now the output layer will come after the hidden layer 3. So hidden 3. Now what we say is model is equals to model with capital M, and inside this we specify inputs is equals to visible, and outputs is equals to output. Now here I'm giving inputs as my input layer and outputs as my output layer. Okay. Then I'm returning this model. Now let me run this cell. We need to assign it to a variable. So model is equals to, let me call the function ann underscore model. Let me run this cell. Now let us check our model summary. Model.summary. Now let me run this cell. So this is the model, and here it is telling my model is functional and it has an input layer which has a shape of 4 neurons, which has no learning parameters. Second, we have a dense layer with 8 neurons, another dense layer with 10, another dense layer with 10, and the last dense layer with 3 neurons. And in total, we have 273 learnable parameters, and the total parameters is also 273. Now, let us compile the model. In order to compile the model, all you need to write is model.compile, and I'm giving optimizer as Adam, and I'm taking the loss function, which is loss is equals to categorical cross entropy, categorical underscore cross entropy, and I'm taking a evaluation parameter metrics is equals to accuracy. Now let me run the cell. My model got compiled. Now let me train my model. In order to do that, all we need to write is model.fit, and here x underscore train comma y underscore train and epochs. I'm taking 100 epochs again. Now let me run this cell. See, this is the loss and accuracy that we are getting. It got trained for 100 epochs and we got a loss of 0.43 and accuracy as 94%. Now let us evaluate our model. In order to evaluate our model, all you need to write is loss comma ACC, the accuracy. We only get the loss in evaluation, but since we are given evaluation parameter metrics as accuracy, we also get the accuracy. Okay, so loss comma accuracy is equals to model dot evaluate with x test comma y test. Now let me run this cell and let us print the accuracy. We got 100% accurate. Okay, so this is how you build a functional API. In the next video, let us discuss about the observations made in this case study.